right. Looks like we are live on Zoom and streaming on Facebook for our February Live with Nassim session. Welcome everybody. Welcome everybody coming on to Zoom, and welcome everybody coming on to Facebook right now. We're always really happy to have this time with Nassim for you guys to ask some questions and to have a little participation in the Resonance Academy. We're so thrilled that so many people have come into the Academy since we made it free. I guess it's last year now. It seems like it's still all 1 year, but really getting a chance to dive into some great topics together. I want to remind everybody that's coming onto Zoom now to be sure to set your chat to all panelists and all attendees, so that when you put messages in the chat, it's not just coming to the panelists. So check your setting there in the chat. I'm going to post this little note right now to remind everybody of that. And also to post a question or two in the Q&A section that we can see there. There's some coming in right now. Appreciate you guys putting in some questions. And then there's also the voting function, which we used somewhat today, and I think I'm going to deviate out from it a little bit as well as we go along, try to get to some, just, see what the questions are in general. Yeah, and so this is our monthly chance to hang out with Nassim. So hey, Nassim, welcome. Good to see you. Yeah.
Good to be with you. I'm very far today, far in the cosmos on another planetary system, having a good time.
Nice job.
You
got a good signal. The Wi-Fi is good there.
I've got the Galactic Federation showing up to take the delegate course,
That's
the Unified Physics course. They're zooming in from everywhere.
Nice.
Different kind of Zoom.
Yeah, right, exactly. Hey, so you were at the Gaia-sphere over the weekend, right?
Yeah.
Did some presentation. Yeah, tell us a little bit about what that was about and how it went. Yeah.
Yeah, it was fun. It was fun, 9 hours of presentation starting on Friday night. And yeah, we went through all the physics and some of the physics and on Friday night and Saturday. And then we did Ancient Civilization and Technology on Sunday. That was awesome. We had a really amazing crew, an amazing audience there. There was social distancing, so it was small, so it was cozy, and it was great. We had a few thousand people listening live, and I'm sure a few thousands will continue to watch it, in the next few weeks. But I think it was fun to be able to present some of the new physics, that I've been doing, and some of the new investigations I've been doing in archaeology as well. So that was, it was great to, bring some more material to the platforms and inform people on how things are moving. And as well, having enough time to get into more of the details. So that was great. And the Gaia TV is a great crew. And Sid was there, the producer of Quantum Revolution. So that was fun to hang out with Sid as well, and talk about possibilities of next episodes and updates and so on. So lots of great fun for a week.
Fantastic. So did you presented for 9 hours yourself? Were there other speakers, or was it all your presentation?
Yeah, it was all me. Yeah.
Oh, nice, great.
Yeah. So that was fun. And it's at Gaia Sphere, which is a studio that, very nice environment. So it's a
It's
great
a very,
thing to be able to do this at Gaia, and encourage as well this kind of platforms that are bringing material that hopefully is a little more, um, let's just say, enlightened than
mm,
than the mainstream media. I'm
no kidding.
sorry to
It's
say.
not hard to do these days.
Well, I was trying to be politically correct, but I couldn't find any other word. The the mainstream media has its place. It's just nice to have a place where you can go and listen to material that
Mhm.
is from a different source, and investigating different things that the mainstream media is not necessarily interested in investigating.
Yeah,
And certainly in physics, to have the time to explain physical theory in details and so on is not something that the mainstream would necessarily
mm,
have. So it's a place where you can actually go and get this kind of information,
right.
and get some of the details. So it's great. It's a great place, and it's a great platform.
Yeah, and as we've said many times, it's so important in the times we're in to be able to communicate the perspective of the unified science and unified physics,
Yeah. It,
because
it
it really provides a foundation of understanding that is necessary to have in order to make the shift that we need to make in this world. So it's really a benefit that they can provide that.
yeah. And it doesn't mean that I endorse or agree with all the things that are on Gaia's platform. I just
Yeah,
think
sure.
it's really great that you can go there and you can make your own opinion about various subject, and some of them
Right.
are things that you may agree with, things you may not agree with, and that's all good. That's just part of the conversation, and so that we
Yeah,
can all
exactly.
evolve and transform, and get to the next level. And to have
Yeah.
a platform that can go there is great too.
Do you know, Nassim, what the plan is? Like, are they going to make some episodes of this presentation you did and then put it on Gaia
It's already
sometime
on
soon?
Gaia. People can go and watch it.
Oh, great.
Yeah,
Awesome.
yeah, yeah.
All right. I'm gonna do that. I haven't seen it yet, so I'm looking forward to that very
Yeah,
much.
I think it's fun. And yeah, you can pick the subjects you're more interested in. I would suggest
Yeah,
definitely watch the physics, because it gives the foundation for the rest.
great. We'll
And
do
as
that
well,
for
it was
sure.
great for me to be able to be philosophical about the physics. And actually, I discussed, in more detail than I usually do, the relationship between philosophy and physics, and how in general it's misunderstood. Philosophy and physics are one thing. You can't separate them. When you separate them, you actually can do mathematical modeling that can lead you astray, meaning you have to be able to have, and when I mean philosophy, I mean it in a very strict way. I don't mean, like interpretation of philosophy that are much more, that can be much more spiritual or so on. I'm talking about straight, um, um, uh, mind experiment, or, thought experiments that
Hmm.
are at the base of understanding physics, meaning that it has to have some observable relationship to what you're expressing. So, so that it can't just become a mathematical model that
Right.
is completely divorced from the observational reality. And what I mean by observational, I don't mean it just in the senses of a human being observational. I mean it in the measurements we're making and everything and of course, that's where physics comes in because it connects philosophy with mathematics, right? Basically,
Mm,
it shows that there is a physical relationship between things that that express the observation of the universe under mathematical constraints, right? The mathematics are just the way to express the relationships in such a way that you see a pattern in the relationship, or you see the pattern of the relationship, meaning that the mathematics is saying this is equal to this, right? And from these relationship of equalities, or relationship of um, uh, gradients, you
mm,
can define the relationship between densities, for instance, and energy and mass and volumes and surfaces and all these things. They all end up equaling an understanding of the physical structure of space that from which you're developing philosophical understanding, for instance. So for instance, the fact that then the universe is uh, a um, fundamental, um, so that structure is relationships, and relationships
mhm,
are dimensionless numbers, meaning that they don't have units to them. They're not centimeters, they're not mass, they're not energy, they don't, because they're ratios. The ratios of
mhm,
these things have units, right? The ratio of these things have units, but they cancel out so that you end up with a dimensionless number. And these dimensionless number then are like the structure relationship, the larger geometry of the system, right? Because they're ratios.
mhm.
And when we extrapolate from the ratios one value or the other, we actually write the units, which is the
Mhm.
physical interaction of these units, of these two values relative to each other. So that units is what the human does,
Right.
ratios is what the universe does.
Yeah.
Uh,
Interesting.
So this is,
It's
for example, one thing that I explained during the weekend.
that's really cool. And kind of to me, it sounds like the the measurement observational universe of units is what our attention is has really strongly been on, and
Right.
that part of what you are focusing on right now. I know this next paper is going to be very strongly bringing greater awareness to the relationship ratio aspect, because it's really kind of ultimately all about relationships and how they're interacting, and then that
Well,
comes down into the
yeah,
units.
the
But
holographic mass solution is already a ratio, right?
yeah,
Which I
right.
named in 2012 to be the fundamental ratio of
Yeah.
the division of space, right? And
Right.
now I've proved it. So you can write space-time in 5 iterations from the sub-Planckian
Yeah.
level to the universal level. And you get the
Right.
right values for the energy level, for the masses, for the radiuses, like all that comes out. So,
Right.
so of course, so yeah, it's already done. Like that, the fundamental ratio has been found, right? Which is
Yes.
basically a surface to volume ratio. It's the
Sure.
surface of a sphere relative to its volume, and the geometric implications of that, and the proton, the electron, the stars, the galaxies. So there's the scaling, right? But in each scale, if you look at a scale, you can find mass, radius, energy,
Mm.
forces. You can find all these things, which is the units we
Right.
have to define these forces, meaning, or these effects, the energy effect or the mass effect. We write it
Right.
in units of mass, for instance, right? That we equal to energy and all these things. And these relationship then are, the the relationship of like taking a frame of reference in a very specific scale, and then to relate this scale to other scales. So, for instance, the strong force with the gravitational force,
Right.
the electromagnetic force, and the weak force, which is, these are two opposites. For the gravitational force and the strong force are attractive, the electroweak and the electromagnetic force is repulsive, right? It's expensive. And
Hmm.
so the mm, relationship of the two, they find very specific ratios as well. Mhm. So, and
Yes.
what I mean by the two is the two directions, attractive or
Yeah, the
repulsive.
radiative and the gravitative.
Yeah,
Yeah.
exactly.
Hmm.
Which is
Right.
four forces. And so all
Yes.
this,
Well, this is one force, right?
it's one force. It's the
Yes.
information moving in or the information
Yes.
moving out. And the
And then
feedback
the relative.
and the feedback
Hmm.
between the two is the information, structure of space-time being able to self-cohere and grow and become more complex and so on. Because the
And then
geometry
it's the
of space,
relative interaction.
yeah, because it has feedback, so it can learn,
Yeah.
right? So
Yeah.
if otherwise, if it's random, it wouldn't organize, right?
And it has relative qualities or characteristics of that organization at these different scales, which is why the thought was that there were different forces, when in fact it's just different characteristics of that,
Of the same force, of the same
of the
dynamic.
same
Yes.
force in the different feedback
Yeah.
ratio relationships relative to these different scales.
Well, it's more rigorous to say in this context, it's
Hmm.
information, direction of information across the event horizons of the scale.
Yeah.
So
Nice. That
if
makes sense. Yeah.
because it's not esoteric, it's mechanical, literally. You know,
Yeah.
is
Yes.
the
Yes.
the surface of the volume of space is oscillating and exchanging information between the inside and the outside. So you can think of like an oscillation on the surface in which you have waves, oscillating. And when the wave is negative, there's information going in. And when the wave
Oh
is
yeah.
positive, there's information coming out. So that, you know, ground, if you'd like, would be the surface
Hmm.
of the sphere. And and you can think of the information flow being the gravitational field and the electromagnetic field. These are in very specific ratios because clearly, the ratio between the electromagnetic field and the gravitational field defines um, defines fundament like boundary conditions, uh, and these boundary conditions, there's more complexity, but you can imagine that the information transfer at the surface of the horizon is um, produce a gradient of its own, right?
Mm-hmm.
Because there's a certain
Mm-hmm.
pressure, right? There's an
Mm-hmm.
information that's coming out and the information coming in. This ratio of information coming out and coming in, we know now is mass, right? It's the energy of the system because of my
Right.
equation on the holographic mass solution. So
Right.
that energy dynamic, you can imagine, has a gradient, and that gradient
Right.
is very high, very close to the horizon, right? And
Mm.
so the force varies from a long range force to a short range force, very
Yeah.
close to the horizon. And that I put in a, in a not so rigorous way in the holographic mass solution. But I finished now this.
Nice. Right.
So um, but I described the concept in that paper. I just didn't have time to get into it. But in that paper, I already calculated the interaction time of the strong force
Yes.
and, the variation in the mass at the horizon that produced the Yukawa potential, which is
Drop
the
off distance.
yeah, exactly, the drop off to the distance. And so,
Mm-hmm.
you can over and you can do the same thing for the electroweak and the electromagnetic fields, so that you have basically like a relationship of force that is um, more clear in relationship to scale, because the theory that you're writing is not linear, but it's a scale relationship, right? So it's scaling law. So
Yeah.
you can relate the scales, because again, it's all relationships. Um,
Yeah.
they're the units is the way we measure things.
Yeah.
Mhm.
Great. That's a fantastic introduction to, well, not an introduction, a perspective on what I probably would consider sort of the essence of that which informs all of the unified physics. Right at the core of the understanding is the ratio relationship and
Yeah,
that gradient aspect. There's some questions here that I think are good ones to just jump into, um, relative to what you've just been talking about. I'm going to go not necessarily right away into the voting order here, everybody. Thank you for voting up questions. Um, and I'll remind everybody that's here, we do like to invite participants on screen. And if you'd like to come and say hi to Nassim, I'll bring you up as a presenter and you can uh, turn your video on, and I'll know that you'd like to say hi. And if you don't want to do that, you can leave your video and your audio off. No worries. Just that will let me know that you just want to stay incognito, and that's all fine too. Um, but there's a couple of questions here, Nassim. I think we could just start with one. I want to bring on Bob Anderson, who's asking about the relationship between the phi ratio, as we most popularly know it, and the Fibonacci, and saying you will have more to say about it, but did not see how this 1.618 constant fits into unified physics. How does this phi relate to the phi universal scaling constant that you discovered? And I think there's kind of two things to address here. One is that relationship of what you call phi, that designator of a ratio used commonly in physics, and the commonly known 1.618 phi ratio.
Yeah.
And then also how you
The
define
phi I
that phi
defined
ratio
is,
and scaling.
yeah, the phi that I defined is not commonly known in physics. It's you could actually find a Galileo constant that is a surface to volume ratio that I think so we could quote 16 whatever, but the phi ratio is like the 1.618. Hi, Bob.
Nice to meet you.
Nice to
Nassim.
meet you.
What an
Where are you
honor.
at?
Bob is a friend I've known for a couple of years now. Really happy to see you here, Bob.
Yeah, well, I've been
listening
in, but it's great
He's
to
been
finally
doing some
get on.
very interesting discoveries himself over the past couple of years, and has shared that with me. And
Oh yeah,
he does some very great work with leadership around the world. So great to see you here, Bob.
Yeah,
nice
great
to meet
see
you, Bob.
Yeah, you too, Nassim.
Where are you at?
I live near Toledo, Ohio. Nice
Okay.
snowy, cold day here today.
Mm.
So
You get to ski?
I do, but I haven't in a bit. I'm busy. So
Get out there.
I know.
There
I
must
know.
be powder.
Well, you got to go up into. There isn't much skiing in Ohio, right? It's pretty
Right.
flat.
Yeah.
So,
Yeah. Okay. Well,
I understand. There's a big difference between, the constant that you've developed, the scaling constant, and phi. I'm just curious because I did a whole paper. There's a whole story that Marshall's familiar with around how this paper kind of downloaded, and that's what got me connected to you, Marshall, was trying to figure out what this was. And I was doing all kinds of geometry, which led me to, star tetrahedral geometry and the flower of life geometry, and then mapping Fibonacci, patterning it to that whole structure. And then I realized when talking with Marshall that it was actually patterned to the vector equilibrium and to your 64 star tetrahedral structure. So I wrote all that up, and then I was shocked when I read the physics paper that that's the very geometry that's required to calculate, right, the constant that you came up with, the pixel, to kind of what do you call it? Pixelize the
structure of space.
Structure of space, and I'm like, wow, this is too amazing. So I'm real because I've been working with all that phi and Fibonacci, and then I find out it's very inherent to that structure, and you labeled your constant phi. So I'm just curious around how the phi constant fits into this universal physics that you're evolving.
Well, yeah, I can pull it out of the physics if I haven't, because it would be controversial. So I'm waiting to publish this next paper, because then I can publish a small paper just showing. I mean, from the paper I'm about to publish, you will be, if you got the right idea, you will be able to pull it out, right?
Yeah.
Because the geometry is inherent.
Mhm.
And the relationship between fourfold geometry and fivefold geometry is phi, and the two are involved in the structure, this structure of space, because you have surfaces, which is fivefold geometry, and volumes, which is fourfold geometry. So you have a, you know, a geometry, like it's not just tetrahedron, it's how the tetrahedrons are deforming to to um, to produce the surface of a sphere, right? So it's going through the 5 platonic solids as it goes from one side of the horizon to the other, right? Think of if you want to think in 2D, think of like in trigonometry, you know, think of a a right triangle that's
Yeah.
squishing, you know, that's changing, you know, that's squishing, like as like, let's see if I can, that's squishing like this, right?
Mm-hmm.
So it's squishing like this. Actually, there's a great thing that was discovered um, in like last month, I believe, uh, papers that were published by mathematicians, two mathematicians that found that they could solve an ancient Babylonian tablet for a trig in base 60 that is much more appropriate than our current trig for this, the expression of the change of a right angled triangle. So because in sexagesimal, in 60 base math, you have integers of division that are, you know, much more appropriate than sine cosine you know. So this is I find that nice from some of the most ancient civilization on the planet came out, you know, better trig
And
than
we have now better trick than we.
2021.
Yeah.
Yeah,
I read that. I read that.
yeah,
That's astonishing, really.
yeah, it's
Their trick
remarkable.
tables are more accurate than ours are.
Yeah. So there's this, you can think of it this way. Basically, as it moves through this very, you know, from the volume to the surface, the phi ratio is produced.
Now, Nassim, just to be clear, do you mean the golden ratio or the
Yeah, the
your
golden ratio.
okay,
Sorry.
the
Yeah,
golden ratio? Yeah,
yeah.
yeah.
The golden ratio.
Hmm.
The relationship of and which is the Fibonacci series, right? Because it's
Right.
relationship,
Yeah,
right?
yeah.
The mathematical expression like is a limit on the Fibonacci series, meaning the Fibonacci series approaches it to infinity. um, the mathematical limit is the phi ratio, like given as like
Right.
1 minus or plus the square root of 5/2, or you know. So
Mhm.
basically, this now you can think of like as like space, you know, compressing and changing into the surface, like one bit of information from the volume pops out into the space outside. And so the space outside is divergent, right? Because it's it's not converging, it's diverging. If you like had vectors on the surface, right?
Hmm.
And the one that goes in is converging vectors, right?
Hmm.
And the converging vectors is gravity, and the diverging vectors is electromagnetism.
And Nassim, the in your scaling law paper from many years ago with Elizabeth Rauscher,
Mhm.
you identified golden ratio relationships across all the scales as well.
Yeah,
And now
correct.
you're updating that in the new paper.
Mhm.
Is that all still, I mean, I'm sure it's still holding up, but how does that fit in?
Yeah, the paper I did with Rauscher where I mentioned it, uh, was basically a scaling law between angular momentum or energy level and radius of a system. And
Right.
there was interesting relationship between the scales that express rough approximation to the phi ratio. We're talking about scales across the whole universe, right? So,
Yeah.
if it's in the if it's in the 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 range, it's acceptable. So I was just mentioning it. But and I was mentioning as well, I think I mentioned that, like, if you take the microtubule of the cells, you end up
Right.
kind of in the middle.
Yes.
But that was really really rough. The paper I'm finishing right now is extremely precise. And
Yeah.
so, the phi ratio doesn't come out in the same way as, like, in the scales, meaning it's still there, but it's rough. Mm, If, but you can output it from the math itself because it's, at the quantum scale is where it's very precise, right?
Great.
Because
I'll
we
look
measure at the
forward to
quantum
learning.
scale. I'm sorry.
I said, I'll look forward to learning more. I probably comprehended about 1/10 of that, or maybe more.
No, no, you'll get it.
I'll
It's
listen and
simple.
keep working my head
You'll
around it.
get it.
Help me.
Hey,
Uh,
while we have Bob here, he has another question, which is it's been voted up as being pretty popular here in the list. So let's jump into that one, and then we'll go into some of the others. So this one's Bob. Bob is asking: the spiritual traditions reference different realms. Shamans and healers describe different levels of the auric field: subtle, mystical, causal, non-dual, and divine levels of consciousness that are connected to nested holons of manifestation. All are described as fields, realms, or dimensions. How do these levels relate to the vacuum as you describe it in unified physics?
yeah, it's pretty straightforward. Meaning that, like, many of these things that are described in spiritual traditions are basically intuitive knowing of how the vacuum structure functions and how we're exchanging information with the vacuum structure, which includes, on certain scale, thermodynamics, like literally, radiating almost at 100 Fahrenheit, for 80 years or 100 years. Um, Maybe 150 years soon. Um, the, this capacity to interact with the field and producing consciousness, even then, the electromagnetic radiation at very high level, at um, the chemical changes, all these things you can assign to, like, what is being described. Is just then it has more rigor because you have a capacity to calculate these things, and then as well you can start looking for them. You Meaning we could do experiments, hopefully soon when there's more interest, to try to measure these things in some level. For instance, the idea that when you die there's some grams missing has been around. It's never been re-verified. Doing these experiments would be interesting. Or even when you sleep. Now, I met physicists that were doing very, very precise measurement of when people were sleeping and were finding anomalies. But I never got the data back, and I don't know if it was published. I'd have to look for it. But things like that, I think that there is, you know, all kinds of ways that we can think of to measure um, this information transfer. However, um, more interesting for me is being able to write the math for it, because if you write the math for it, then you can account for consciousness and everything. You can account for why, you know, you're even having some spiritual experience, whether you're having it or not. Just the fact that you're conscious on the planet is already what you could say in the spiritual experience. So, you know, if you can write the math for it, that'd be cool, because then you understand how it works, you understand how to maybe make it better, amplify it, you know, like be able to live longer and um, travel further and produce energy and all these things. So for me, that's a really important part of understanding this. And as well, it removes dogma, because you understand the mechanics and the physics of it as something that is, you know, part actually the source of reality, meaning like information and the structure of space-time and so on. So it's no longer like spirituality and consciousness on one side and physics on the other.
No.
Just it's unified, you know, in such a way that the mechanics of space-time is, you know, attached to the concept or the idea, which, you know, it's an oxymoron, because you're saying the idea of consciousness. Well, you know, in order to have an idea, you have to be conscious. So it's difficult to express, but the source of reality and the fact that the system can be self-aware are unified, you know.
Yeah.
Yeah.
I'm trying to figure how I want to frame this for leaders. We're actually bringing this work now into our leadership work as, you know,
Mm,
fundamental consciousness, and
mm-hmm,
you actually need a unified model in order
mm-hmm.
to lead lead at the level that's now required of leaders in the world.
Sure.
And so I'm really working with, because the
Especially if
tradition,
we want to unify the world.
exactly.
Yeah,
Uh,
it'd be a good start.
we have to if we're going to steward this planet, right? So, but I've been picturing it the way the traditions do. It's like fields within fields, interpenetrating fields. And Marshall, you and I have this background in the Barbara Brennan School of Healing,
That's right.
where Barbara was a
Yeah.
physicist, described the auric field, and you describe this in cosmometry, right? The layers of the field.
Right.
And Barbara talks about the body doesn't give off an aura. The aura actually precipitates the body into form and holds it in form,
Right.
right? So the field is precipitating form, informed, right?
Very good.
So,
Very good.
Yes.
right?
Very
Yes.
good.
So is that just, are those levels that's been described just frequency bands or octaves within, um, you know,
It's
You could
it's the
think
same
of it.
gradient.
Yeah, you
is it
could
the
think of
same
it as,
thing, or are there,
yeah.
are these other
The
realms or
information.
fields precipitating what we call now the vacuum? Or is it
No,
all
no, no,
just the
no,
vacuum?
no, 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 no. There's only the vacuum. There's only the vacuum. No, no, but that's how you deunify. You know, this is a very, very prominent thought. It's very, very insidious. It
Mhm.
has permeated the human consciousness very long time. You know, the idea that there's something different than what is. You know, you can say it's all an illusion, and you can put an equal sign and put it's all real, and it will be a complete, you know, thought. But you see, you can't say, you can't divorce the observer from the observed, right? You can't um, you can't divorce the information flow can only be unified. Like consciousness can only come if the information flow, right, is unified, meaning that there's the part is receiving information and the part is contributing information, right? So there is constant flow. So you can think of, okay, so let me make it clear. You were describing octaves or like harmonics relationship of these collapsing bodies, right? As information collapse, right, into form, if you'd like. Okay. You can think of the information going in, but then there's information going out, right?
Right.
Well, the basis of quantum theory is a calculation on a black body radiation spectra. Okay. So now replace your concept with a black body radiation spectra. So a black body is a body in which all incident light, like all photons that get, close to it, get absorbed, right? So you could make that a black hole and it's correct, right? A black hole is a perfect black body. Okay. And then the radiation it emits, that is, it's gonna heat up. So like if you have a black box, like that's a really good black, it's gonna absorb photon and heat up, right? So it's gonna radiate thermodynamically. And that spectra is what Max Planck, solved. And outputted the Planck's constant, which is the quantization of space-time that eventually Einstein, used to describe the photoelectric effect and got the Nobel Prize on. And okay, so this is like a very fundamental part of electromagnetic and thermodynamic equations, right? That are at the base of quantum theory. So those body you can equate to various frequency on the spectra of the emission of the black body. So now make every proton that you're made of a mini black hole. Okay. And then imagine all the information moving in, and then the thermodynamic emission being the information that's moving out. Okay. And so now you have the, what you were saying, the collapsing into form part, which is the material form, right? And the resulting electromagnetic bodies that are emanating, which is the thermal effect of collapsing information in that region of space.
Interesting.
All right, explain that to the CEOs, Bob.
Yeah, we're working on it. We're working on it. It's how to accurately and elegantly synthesize it. So
well, I think it wouldn't be that hard. If I write it, you can probably describe it.
Yeah.
Bob, let's connect on that. Let's have a follow-up conversation about that. Since you're riding that edge and wanting to communicate that would be an important one.
We'll talk later. Great. I'll let somebody else on. So thanks so much, Nassim. Great to meet you.
Thanks, Bob.
We'll have to get you in front of some leaders.
I'd love
at some
that.
point. Yeah. All right. We'll do that.
Okay. I'll talk to
Good to see you,
them.
Bob. Take good care.
We'll have fun.
You
Nice to
will.
meet you.
You too.
All right. Just since we're on that topic of consciousness, we'll go to Anton's question here, which is, do you believe there is an equation for consciousness? If so, what progress have you made in finding it, and what applications could the equation have if found? I suspect this relates to the sub-Planckian scale analysis that you've been
Yeah,
discovering.
I just described it, but
Yeah, do you want to just leave it at that, or?
yeah, information moving in, information moving out, the relationship between the forces and the scales, yeah, you
And
can.
is there how would you see an application of that relative to this gradient of consciousness potentially?
Hi, Anton.
Hello, Nassim.
How you doing?
I'm doing well, thank you.
Where you at, bro?
I'm in Lewis, Delaware.
Right on.
First town, first state.
Right
You
on.
know? Yeah.
Yeah, you're at the origin.
Can't believe my question was called on. I've got a small confession. Well, we were in the breakout group last week, and Radu mentioned that you had Radu said he knows you, and he said that you were working on an equation, or maybe had mentioned something about it. So I figured I'd ask it. But my confession is that I really would just want 90 seconds to introduce myself to you, you know, because this is such an incredible opportunity.
Thank you.
Yeah, thank you very.
Nice to meet you.
Thank you very much. I wrote a patent to enhance a CBD molecule with sound and light. And
cool.
And you know, it's what it started me on the driving to do research with you and YouTube and more, you know, join the Renaissance group and just constant research. But I started out doing work with the Native American Church for 5 years, and we traveled around and we did a lot of work. We helped a lot of people with this, so I know there's something to it, you know. And
oh, that's good.
You know, so
that's good. That's good. Are you an engineer then?
You know, I grew up in the restaurant industry. My family, I was pushed around in the basement in empty liquor boxes by my grandmother growing up. You know, I joined the Native American Church for 5 years. We traveled around the country and we gave people intermuscular injections of CBD. It was a somewhat gray area, a little bit of maybe illegal. So I wanted to take a step back and offer this technology to the public in the right way, you know. So I was under pressure. I left and I wrote a patent incorporating what I learned with sound and light, and I mushed it together. I found out that light can absorb matter. You know, when light passes through a compound, energy from the light can be used to promote an electron from a bonding or non-bonding orbital into one of the empty anti-bonding orbitals. And so what I was trying to do was incorporate the benefits of sound and light and cymatics and nano sizing with you know, ultrasonic vibrations, and it all kind of relates to the field and understanding the relationships and the different God, it's so interesting what you do. I swear to God, I spend hours a day focusing and just studying and learning, and I appreciate it so much how well you describe it. You know, and I just
appreciate. Thank you. Yeah, well, you know,
I don't even remember what my question was, but
it was about consciousness.
Well, Mr. mostly answered it before anyway. So.
Yeah. So, but it's interesting your interest in chemical interactions and light and sound. Those are good avenue of research. I'm glad you're doing the research first. You know, is a good thing. The before doing anything else.
Well, sure.
And I'm happy that this is a good point. Is that in material science, there is a certain amount that's known about the structure of matter, um, but and there's a lot that's unknown that has to do with how the forces emerge to produce these effects, like the bond interactions and the van der Waals force, and the Casimir force, and all these things. And so um, you know, as well as like the absorption of photons and the vibrational relationship of the whole system, but collective vibrations, not just individual interactions at the chemical bond relationship, but the collective behaviors in the medium, right? Like wave functions in the medium that like you can produce by sound,
Right.
and so there's that
Right.
interaction, and the photonic interaction together is a good idea.
So since I just have you, I just want to show you, this is the laser I created going through a custom cut crystal into like a mirrored tube,
Right on.
right? I'm working on different applications with different boxes and mirrors going in with like crystals at the bottom too, little pyramids or something. And then I got a magnet at the bottom,
Right on.
just real, yeah. I've joined your group. I'm trying to go to every meeting possible, the breakout sessions, and I just
Fantastic.
I just really support
Thank
you guys.
you.
Thank you guys.
Thank you.
Well, thanks for being
Appreciate it.
here.
Keep
Thanks,
inventing
Anton.
out
Thanks for
there.
being here.
Keep at
Yeah,
it.
keep inventing.
Thank you very much.
Yeah, keep inventing. Keep going.
All
We
right.
need help.
Take good
All
care.
right.
Yeah.
See you again. All right.
See you later.
Bye-bye.
Thank you very much.
All right, Nassim. Well, let's see. At the top of the list here is one from Luke, who's asking Dr. Stephen Greer puts a lot of emphasis on the fact that there are no bad ETs and that 95% of the info available on the web, even on Gaia, is contaminated with this erroneous info by people pushing an agenda of fear of ETs in order to justify a Star Wars on a large scale, and that many ships and their occupants have been downed by this group. What is your position on this?
Well, this is one thing that Dr. Greer and I always agreed on. And so it's a good question. Yeah, I would probably come to similar conclusions. And mostly because from logic. First of all, if there was ETs that were trying to get us, if they've come from even the nearest star system, they probably could get us pretty quick. I don't think it would take long, and it wouldn't necessarily. They could probably like turn all the power off the planet, like the whole planet, almost instantaneously, with one MP hit. And our electrical grid is very susceptible to EMP, and so on. I mean, you can go through the logic, and so basically, if there was negative civilizations around our planet trying to take over, it would have been done. And it's all the evidence that you see of UFO interaction with military personnel are evading maneuvers by all the crafts, the ones certainly released by the Pentagon in the last few years, and actually in the last year. Clearly there's no aggressive behaviors. And I'm pretty sure from the data I've been getting over the years that there's been aggressive behaviors from our uh, guys. And I think that if that was happening in a context of aggressive race of extraterrestrial, like I said, we would be done by now. So I doubt that that's happening. And like I said, I don't agree with everything that's out there, and um, this is just from pure logic, or even just
That makes
um,
sense.
yeah, and from data that like there's no evidence of aggression. So if they were aggressive, you know, there's another way to go through that logic as well, is that the mm, the way we think of consciousness evolving, when consciousness evolve, if it evolves to a point in which it understands the structure of space-time and is able to go across very vast distances, then it understands as well that it's all one thing, and whatever you do that affects the one thing negatively has a negative impact on you and on your civilization and everything. And so it's best to actually impact the structure of space positively. And so
Mhm.
self-destructive behaviors in nature eventually, self-destruct. And they don't get very far. You can see it. It's quite quick that nature takes care of that.
That's true.
So the idea that you could have got to like galactic capabilities and not learn those lessons are, I believe, very, very low, very, very low.
Right.
So,
Yeah, that
uh,
does make a lot of sense. It's very logical.
so, and Dr. Greer agreed with me when I talked to him, and mm, he is coming from logic as well and direct interaction, and so you know, and so I think it's valid, it's logical, and it's valid experience.
Yeah, great. Very makes a lot of sense.
Mhm.
All right. I've got another physics question here for you from James Weinberg,
And
which I think
I,
ties into
maybe I
what.
should add just one thing, is that
Yeah.
um, some of the stuff that's been promoted is, as in the question, to um, produce fear in people so that they
All right.
will follow certain, approach to how we would want to interact. In some of the documents that were declassified in the last few years, there is clear statement from the military personnel that the interactions don't seem to, don't don't seem to be aggressive. That they don't seem to be aggressive. That they're just coming in the airspace, and the
Mhm.
military personnel has to investigate what comes into the airspace. But so that's So there's interactions that may be, not so clear for our perspective of like the intent, but clearly the intent is
Mhm.
not being, destructive.
Right. So there is some fear propaganda, we might say,
Mhm.
that could be serving an agenda for a space force, so to speak, but it's not really relevant to the actual
Yeah, the concept of the
engagement.
Space Force in itself is not a bad concept. It's just hopefully it's a Space Force that's benign and
Yeah.
you
Right.
know and that is willing to interact in a way that's positive for everybody, which seems to be demonstrated on the other side very clearly.
Right.
Because when you're getting shot
Thankfully
at,
so.
you know,
Yeah.
if all you do is evading moves, I think that's
Yeah. Yeah. Yes. Great. Okay. Next question is in, why are protons so everlastingly stable? It's an interesting question, I think, especially in relationship to what you were describing in the
yeah.
beginning of this, uh, because it's this particular point in that whole scaling of harmonic ratios where we find this foundation of the entire matter of the universe that just goes on and on and on and on without decaying.
Mhm.
Protons, the half-life of a proton is 10 to the 36 years, I think, something estimated, guesstimated.
Yeah,
uh,
that's a
age of the
very
universe
large
is 10 to the 9.
estimation. Yeah, that's a very
Yes,
large
yes,
estimation because in
yeah,
13.8 billion years, we haven't seen any decay so far, right? Like
yeah,
measurement,
yeah,
measure.
right.
So that and that's based on very specific theoretical approach that is not considered very solid. Mm,
Mhm.
but that's another thing. Um, but this the reason why. Hi, James,
Hello. Hi.
where you at?
I'm in Nashville, Tennessee.
Oh, right on, right on. How's it down there?
Well, it got cold,
Oh,
but I'm glad. I want some semblance of normal. I don't want summer in January.
right. Is it snowing?
No, barely. No,
Okay.
but it did the other day.
Oh yeah.
No skiing in Nashville, Tennessee.
Yeah. Good music though.
We have great music here.
Yeah. Good party town.
Yeah, all kinds of music too. The whole range. It's not. We've just a broad array.
Yeah, it's great.
Yeah.
Yeah. I like country music actually.
I've grown to like it. I didn't grow up with it, even though I grew up in Tennessee. And
Really?
yeah, but I've been doing this kirtan music. We have
Oh yeah.
that's the chanting, and there's a big community here in Nashville, and
Oh cool.
I play the harmonium, and we
Oh wow.
different groups I play with, and there's all these recording studios here. So my wife and I recorded an album. We're in the mixing stages now, but that's one thing we did during COVID. So that was nice to be able to
Fantastic.
Yeah.
have a creative, and we're really excited about it. So,
Yeah. That's
so
awesome.
Good.
that's a little different
Thanks
than
for
the
sharing.
country
Yeah.
music scene.
Yeah, I would say so. A little, just a little. Yeah. But I used to live in near Calgary in Banff, Alberta, and and all the way up to Whistler for years and all this stuff. And in the summer when I was in a ski pro, I did all kinds of jobs I guided in the mountains, but as well, I did, jobs to get more money because guiding was like barely keeping me alive. But so I drove buses in the mountains, standard buses with double clutches in the mountains with like 37 tourists from all over the world, the groups from France. I did a lot of French group because I could speak French. And then, we would they would love listening to country music going through the mountains, right?
Yeah.
And yeah, so we would do that. And then I would talk about physics in the breaks between the music. And we had the best time.
Great
But
combination.
yeah. So yeah, anyway, so your question,
Yeah.
the universe,
Yeah, I've been thinking about, because I'm still wrestling with how gradient is behind it all, but yeah, the analogy of a hurricane, that kind of gradient dissipates after a while, and I'm wondering, why is this gradient permanent, seemingly permanent?
because it's you have to think as the whole and think of the conservation of energy, right? Energy doesn't go anywhere. So if you look at only one tornado, or one hurricane, you say, oh yeah, there's a gradient there and it dissipated, but there's gradients that are being created as those are being dissipated, right, all the way all through the atmosphere. So you can't see, when you close things into a box, then that's when you lose the global view and the understanding of the whole thing. So yeah, the proton is very, very stable because there's a continuous gradient, right? So you will see dissipation in the universe as well, like a galaxy going from quasar to like a galaxy is like a dissipation, like the system is in some ways losing energy, but it's changing, it's going through phase transition of the energy. Or a star that's radiating, right, so it's dissipating stuff, right? There's lots of dissipation happening, but so basically you have a constant gradient across scales. So you'll have stars that go supernova and dissipate the whole thing, and then you have a black hole left in the middle because you have angular, conservation of angular momentum that's producing a really dense point in the middle. And so this division of space means that like it whenever gradient, where it's dissipating over there, it's like absorbing over here. And so like across all scales, the thing becomes extremely stable, right? Extremely stable. So the proton doesn't go anywhere. It's like a little black hole in continuous, absorption and emission, right? And it's spinning with others and making larger nuclei, which makes larger atoms, which makes large molecules, which eventually makes matter, that organizes. And then the organization of matter eventually makes billions or trillions of atoms together, making cells. And then the cells organize. And you see, like, the whole thing is continuous, but there's dissipation functions, right? Like the system going towards biology is like dissipation, right? At the end of the line over there, it's dissipating heat, right? The thermodynamics. So you see what I'm saying? So
But
are you asking why doesn't it decohere?
I was asking that, and also I was thinking, I was under the impression that black holes on a big scale can actually combine.
If combine, yeah.
But protons don't seem, I mean, they cluster, but they don't actually combine into one unit, do they? Into one proton? They keep
No, that would be fusion.
fusion, yeah, so they don't do that.
No.
So that's interesting that, because you think of a proton as a black hole, and yet it acts a little differently than a big black hole. Is that true?
Well, it's just that you have different density dynamics, meaning that the small black hole of a proton is going to have an electrostatic force that's really strong, right? And and the relationship of the electrostatic force to the attractive force is just right, so that they stay in orbit, right? And so now you have like a stable orbital system, and if it's unstable, then it starts radiating photons, which is what we call radiation, or the electroweak force. So like beta decay and all this stuff. So basically, the system is exchanging, right? But it's a dynamical, stable system, right? And the relationship of black holes at the cosmological level is the same. It's just that there's orbitals that are stable and there's orbitals that are not. So you can think of it as two black holes, fusing at the cosmological level, as like radiating a lot of energy, for instance, gravitational waves that we pick up, very far away. In terms of the energy radiation, the same as like an unstable, and I'm like making a very loose relationship here or comparison, so don't take it literally, but you can think of it as like the black holes orbiting, creating, a electromagnetic radiation, that would be like at the atomic level, the decaying orbitals of a larger nuclei, like down the table of elements, where they start to radiate, particles. Do you see what I mean? So that you can make a direct relationship.
I have to re-listen a little bit, but basically, back on the original question, they don't dissipate the protons don't dissipate because of the universal law of that we have conservation of energy,
Angular momentum.
angular momentum.
Yeah, it's just that if you have a gradient to infinity, if it goes infinitely small, infinitely big, it's going to continue spinning and it's going to be pretty stable, and then as you go small, it's going to get more and more in resolution. As you go big, the resolution gets wider because the boundary is wider. Like, for instance, like all the stars, then you have nothing, right? Then you have galaxies, right? All the galaxies, they're all different size, but they're in a band. And then you have nothing. And then you have like, clusters, right? They're in a band. And then you have nothing. Then you have super clusters, right? And so they all kind of like define scales, right? But the scales, get more and more resolution as you get closer to the proton, the electron, the proton, and eventually to the Planck, where you're at like the fundamental grain. And then you can keep going to the sub-Planck, but that's a whole other story. And hyperplunks is a big problem in physics. For like, there's a problem with Hawking radiation that has to do with hyperplunks, and we solved it, but it won't be in this paper.
Thank you.
All right, great.
My pleasure.
Thanks, James.
Thanks a
Good
lot.
to see you again.
Yeah.
Look forward to your music when it comes out. Make
Yeah,
sure
I
you
can't
post
wait to
music.
share it. I'll let you know.
Yeah, share it into the community forum when it comes
Yeah.
out.
That sounds good.
Great,
Oh, good.
great.
Thanks.
All right, be well.
Nice to meet you.
Nice to meet you.
Yeah, I remember my country music days. It was fun. We
I
had a
can just
good
picture
time.
you singing along.
Huh?
I can picture you with that little, I can picture you singing along with that little twang
Oh
in your
yeah,
voice.
yeah. Oh my God. You can imagine with
I don't know.
47 French people drinking wine, you know. They
Singing
all
country music
yeah, singing the country music in
in
the
the Canadian
Canadian
Alps.
Rockies. Yeah.
The Canadian Rockies.
Yeah, that was us.
That is the bizarre nature of our reality on this planet. Right
Exactly.
there. Summed up into one little-
Yeah, I always felt like it looked surreal from even from that perspective at the time, you know.
All right, listen, we're gonna do one more question. Try to keep this to 90 minutes
Okay.
as an ongoing quest here. So this next question is from Gisela. I presume it's the pronunciation of her name. I'm wearing the ARC crystal now for quite some time. It seems like the expansion of consciousness is and has been speeded up. Events and feelings and thoughts, people are coming in my life who assist to release much more of the limitations. I know it works via the water in our bodies, at least partly, but I would like to know more about the attraction of the events related to the crystal. And you have six minutes to answer that question.
I see. Okay. So what exactly is the question then? I missed.
So that there's the experience of, I'll bring this all up here. There's the experience of having events of ideas and thoughts and experiences and people that come in and help to kind of maybe, remove limitations or come more fully into one's experience of life and what your purposes are. And that seems to be an increase of that since wearing the ARC crystal.
Yeah.
Experience.
Okay. Yeah. I see.
So how would that be explained relative to that?
Hi.
Hello.
Oh, you're muted.
Unmute yourself.
Your mic. Yeah.
Myself.
There you go. Hi.
Hi, good to see you. I saw you when you did your first workshop in Kalani on the Big Island.
Oh, no way.
It's
Really?
100 years ago.
Oh my God. It was in Kealakekua Bay?
No, Kalani. Remember
Oh, Kalani. Oh,
Kalani.
yeah, on the other side. Oh, yeah. That was, yeah.
And it started at 11 and ended at 11 at night.
Yes, it was one of my short ones.
It was wonderful.
Yeah. Oh, yeah, we had a good time. I remember that talk. It was, I'm glad you were there. Well, nice to see you again.
Oh, nice to see you always. I'm just was writing to a friend. I always feel new hope after I listen to you and to the whole, also to the membership meetings. And it is like you have a wonderful talent to explain things in a way that lay people can understand it.
Thank you.
And I use a lot of your examples in talking with friends.
Oh, yes? Good.
I was also a chemistry physics teacher.
Oh, wonderful. Oh, wow. How long were you a teacher?
Oh, in Germany for 11 years.
Wow.
From 6th to 13th grade.
Wow.
And I don't know anything. The more I know, the more I don't know.
Yeah, well, that just happens all the time in science. It doesn't matter how much you know. You still don't know. It's remarkable, but I'm sure you know a lot. It's great to meet you, and I'm glad that you stuck with it all these years, and that you're still with us. It's great
Mm,
to
yeah.
to participate. Aren't you excited? Like we have almost 100,000 people taking the course right now.
Wonderful.
It's great, isn't it?
Fantastic.
Where are you at? And how do you pronounce your name?
Gisela,
Gisela.
Gisela.
Gisela. And right now I'm in Waikoloa, but I live in Kona on the Big Island.
Oh,
Oh,
wonderful.
yay.
Yeah.
Both Nassim and I lived there for many years.
Yeah.
Yeah, I know. I met you more often when you were in the
Yeah.
dome.
Oh, yes.
Yeah.
Nice.
Yeah. So your question was,
About the crystal.
yeah. So what was it?
And I'm experiencing, sometimes it's like a whirlpool.
Yeah.
Things are happening and it
Oh,
is like,
yes. At a faster rate.
yeah. And
Yeah.
whatever you want to share in the last few minutes, I am glad to listen to it.
Thank you. It is okay. So the question includes the concept of time. So I'm gonna have to, you know.
Yeah.
So if time, okay. So is think of time as sets of information on the structure of space,
Mm-hmm.
right? And think of oh, did you listen to the answer I gave to the other gentleman earlier about
Yes.
how that was Bob was saying that like it's like collapsing space that makes the
Yeah.
yeah.
Uh-huh.
So if you increase your collapsing of the space in the region of space, then there's more information that can flow in that
Oh, okay.
region, right? It becomes more coherent, right? And as it becomes more coherent, then you will notice an increased amount of synchronicity, right? Because it's becoming more coherent.
Mm-hmm.
So the information can organize easier, right?
Okay.
And you're listening better because you can hear it better. You can hear where the flow should go better. So you
Mm-hmm.
get better at flowing with the flow, right? And that increased synchronicities. And the little crystal is a way to amplify a little bit that effect because it creates a local collapse in a region
Mm-hmm.
of space that like makes the information flow in that in
Mm-hmm.
a very coherent way in that region, right? And that has that effect on the but it is your growth, it's your increase in awareness, of the field and being able to follow the flow that is making the difference, right? Mhm.
It's also, is it also, of course, it has an effect on the water in the body.
Mhm. Yes,
So
exactly.
kind of organizing, structuring into a
Structure.
higher geometry.
Geometry, yes. Yeah.
Geometry. Thank you for listening to German.
Yeah, no worries. I wish
Mhm.
I wish I had better German capabilities. I should have been born in Switzerland, but I never did so good in German. The yeah, it is the water molecule geometry is really important to the DNA
Mm-hmm.
chemical interaction,
Mm-hmm.
chemical bond. And so this is the part that's commonly overlooked in biology, is the role of the water molecule and its role in holding structures in very specific relationships,
Mm-hmm.
and its role as well in how do you say, modulating these structures from one to the right. So you know this, huh? Straight out of the textbooks. So yeah, go ahead.
I'm working with epigenetics.
Oh, yes.
And with the transformation from the RNA to the DNA, and water is very, very important there.
Yeah. Oh, that's great. Do you have papers I could read? Did you write something about it I could read?
No, you know, I'm also Body Talk with John Feldheim since ages.
Yes. Oh yeah, great. Oh, great.
So I'm a practitioner of that, and it all comes together. It all makes sense, and I'm always excited about it. But again, then it is like, oh wow, there's so much.
Right, there is so much. Yeah, it goes down the rabbit hole very far. This is why, you know, I say, oh, my paper is almost finished, but almost finished in the universe is an infinite gradient. So I'm trying to figure out where to cut it, you know.
We're going to have to
renormalize.
I was going to say, we got to renormalize that paper pretty soon.
That is how I was actually taught to teach. Starting with a question and ending with the next one.
Right. Yes.
Oh, that's great.
Yeah.
That's really great.
And the students had to do the work to figure out.
Very good.
That's so great.
Yeah, that's awesome.
Thank you for joining us.
Yeah.
Go ahead, Nassim.
Just one last question. Were you in the standard educational institutions, or were you in private institutions?
It was in Germany, and you know, they have the division between vocational education and more university preparing education. I provided my students with thermodynamics at that point in time.
I see. Awesome.
Yeah,
well, really nice to meet you.
Nice to meet you.
Wonderful.
I'm so glad. I don't miss one time.
And say hi
so
to the Big Island for us.
And thank you, Marshall. You look so great when you smile. I always think that.
Thank you. You helped me to want to smile. I appreciate
Thank you. Thank you.
And say hi to our dolphin friends out there too.
I do. I do. Thank you.
Quite. All right. Be well.
So glad that you exist.
Thank you.
Back at you.
Thanks for being with us all this time. It's been great.
Yes.
It's wonderful.
Thank you. Okay.
All right. Well, so it's a beautiful place to wrap up here today.
Yeah, absolutely. Amazing.
I just want to mention that we have an event this Friday with Elena Bensonov. It's a Q&A session in relationship to her elective program, which is now available. So this is a free Q&A session this Friday at 12 o'clock Pacific time. And I imagine most everybody would have gotten the email of the upcoming events for this month, and that one is listed right at the beginning of it. So you can register for that again this Friday with Elena. So that's going to be very, very fascinating. And then
Elena is an ex-pharmacist that decided to change her profession to promoting health in another way. And I think she's very interesting, and she's doing amazing work. So I'm glad to have her on.
Yes. It's going to be very fascinating, I'm sure, this Q&A coming up.
Yeah.
So check that out. And then we have our breakout groups, as a couple of people mentioned today. where you can connect with other members in small groups on Zoom, which is always a great experience to do and have some good conversations together. And then in 2 weeks, we have our faculty Q&A again on February 17th at 12 o'clock Pacific time. Yeah, so that should be it for today. I know we got so many other great questions, and
Yeah.
but we got some really great stuff covered. I thought that was a kind of a fascinating journey in the realms of the physics and the information and the scaling and the experience of it and all that.
Yeah, it was amazing. Amazing questions and good discussions, and you know, I think that like a lot of the information that we're able to share at this point is very like people are doing such amazing work everywhere in the world, and we can really transform our world in a very fundamental way at this time and have a very positive outcome for humanity as a result. I think, you know, the work of everybody that participate and everybody that continues to like move the world forward in a positive way, and which includes, you know, really examining our current state of affair um, and um, and really going for the truth. You know, meaning really going for the our highest uh, uh, possibility of unification. I mean, really the first thing that must happen, and that I talked about in like at length during the seminar this weekend, is that we have to unify. Is really the first step. And that means really at the fundamental level, as I was saying earlier, is to realize the universe's relationships, and that all relationships to the universe are important. And so all points of view are required. And you can actually if you can actually have the empathy for another point of view, then when you can experience that point of view from an empathic position, and when you do, then you find values in that point of view as well. And so, you know, that like, so that we have to just massage the thing so that all the values that are positive and creative for humanity, you know, kind of like come together in a unified effort to make transformation on our planet that's required at this time, to a planet that is very that's thriving, and that is transforming and expanding in terms of its reach and its capacity to connect with larger communities and so on. And this is this is the moment, and it's a very important moment, and we need everybody on board, you know. So yeah.
Yeah, that's beautifully said. Like really the shift from confusion to coherence.
Yes.
Rather quickly, I think, you know, the imperative is upon us now. And
Right.
it's time to really act on it, to really call it in and act on it. That's what we're doing here. And that's why having a scientific foundation brings it all the way in. Like you said, it makes it mechanical and physical, not just an idea and a thought or a spiritual context. It unifies the whole of it. So that's what we are here for. And we really appreciate everybody being here with us always. As Nassim said, we got close to 100,000 people in the program now. And you all that come here and join us in these sessions really just make the difference, and we can feel that good feeling of unifying that comes with being together like this, because we see that in your comments and feel it in the field. So we appreciate you all very much. And let's keep carrying this one out into the world, just like Nassim was talking about. So thanks, Nassim, for today.
Thank you.
As always.
Until next time, May the vacuum be with you.
That it is. All right. Bye, everybody. Take good
Bye,
care out
everybody.
there. Next time.
Thank you.